Last week, Paul and I had the pleasure of speaking at the Financial Modelling Summit. Our topic of discussion was the intersection of financial modelling and analytics, and we're just going to share a brief excerpt from that discussion about some of the analytics tools we can use when building financial models. So what are some of the analytics tools that we might consider leaning on when building and using a financial model? Well, the first one is all the way at the start when we're thinking about model architecture, how we're building and designing our financial model. And one of the considerations we might want to make is, how many revenue categories are we going to have? How are we going to think about how we model a business such that we can effectively flex key drivers of the business in a way that's meaningful to the business doing the modeling? Paul, what are your thoughts on some of the analytics tools we could use to inform this?
I would call it statistical segmentation. There might be cases where the grouping is quite natural, that it's quite easy for you to identify these segments. If you think of a large customer base, for instance, they might just be using segments internally. But really, a statistical segmentation is different. Taking the example of a large customer base, a statistical segmentation would simply look at characteristics of a customer and use those to decide on either the appropriate amount or also which customers go into which bucket. So you might know maybe 100 or 200 characteristics of a customer that could be demographics or behavior or interaction with your product or product holdings, and you would use those to group people up.
For the listeners' interest, what are specifically those statistical techniques called?
A statistical segmentation really consists of two parts. There's usually the dimensionality reduction part of the analysis and then the clustering. The dimensionality reduction is really taking those 200 characteristics and creating a more meaningful subset of those. And you might use techniques like principal component analysis or TSNE. Once you have that reduced space, you would use any number of clustering algorithms. That can be as simple as a k-means clustering, or it can be something different, maybe a density-based cluster.
I think the beauty of that is for a business that they now have maybe 4 to 6 simple segments that they can use in their forecast, but there are also distinctions that allow them to take differentiated actions on each of the segments. Another financial modelling classic is budget and forecasting. Often in the financial modelling world, we're building up either a monthly or an annual view of a project or part or whole of a business, and maybe incorporating some actual data into that budget model. Paul, what are some of the analytics tools we might consider using in this circumstance?
Yeah, for me, time series analysis is the perfect example of where data analytics and financial modeling would meet. Time series analysis would take not an assumptions-based view, but a historical data view and build a statistical model of, for instance, demand, your demand forecast, and produce forward-looking estimates. And I think when you try and incorporate external drivers into that. So, for instance, your demand forecast might not only depend on historical patterns, but it might also depend on external drivers such as FX rates or inflation or GDP growth. This is something where time series analysis really shines. From a technical perspective, it may be tempting to think of fancy recurrent neural networks, LSTMs, to do this type of work. But really, the classic methods really have stood the test of time. So think of autoregressive moving averages processes with these additional drivers laid on top of them.
Interesting. And then another financial modelling classic are scenarios and sensitivities. In a financial model, we might think of this as a special scenario page where we're able to flex key drivers or create overlays. You maybe use some Excel functionality like a data table. Maybe you've built a scenario capture mechanism with a button that we can use to capture scenarios into a library and compare and contrast. What are some of the analytics tools we can use for that kind of work, Paul?
I would say you would call it very similar, a scenario analysis, a simulation, or a sensitivity, really. And if you think of the time series demand forecast, a scenario analysis could, for example, be like, what if FX rates were different? Or what if inflation is different in the future? So playing around with the model, you would get different outputs. Simulations is very closely related to scenario analysis. And again, this idea of a demand forecast projecting that forward, the simulation would simply run hundreds or thousands of scenarios. So you would present it with 100 or 1,000 potential future states of the world, and you'd be able to see the distribution of demand forecast. And sensitivity, I would say, is very similar to your next point, Neil, where you talk about elasticities. It's really the sensitivity of a parameter in our model, in which price, for instance, in your demand forecast is again a great example, where data analytics would allow you to not just estimate the price sensitivity like you might do in a typical regression, but it has more flexible machine learning algorithms that could kind of draw a price response curve on a customer level, for instance. So it's much more powerful.
Very interesting, Paul, and clear that we're both building models, we're both running scenarios. It's just different technology, different processes, lots of crossover.